In the last lesson, we figured out how to clear bits using the Bitwise-AND. Now we're going to figure out how to set bits using the Bitwise-OR. All right. Now, once again, we started out last time talking about the fact that whenever you do a bitwise inverse, all you need is the one element. That tilde in front of your variable will flip all the bits of your variable. But we need to have a mask, some method to make it so that we identify which bits get to change, what bits don't change. So we're going to do this operation again. We're going to, except this time with the Bitwise-OR. So x equals A or B. Here's our little truth table. And so 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. Remember the definition of an OR being that if there's a 1 at any of the inputs, we have a 1 at the output. So let's do exactly the same value and mask we did last time for the AND. So we had a value of 10, 10, 10, 10, and we had a mask of 1, 1, 1, 1, 0, 0, 0, 0. All right, and now we're going to do a bitwise-OR. Just a refresher, bitwise operations, the way they work is that the operation is confined in the column. It doesn't have any operation. There's no consequences to bits on the neighboring sides. All you have to do is do an OR of the two bits that are in the same column or at the same position or power of 2. So we've got 0 or 0. No zeros, no ones, so there's a 0 on the output. 1 or 0 is 1. 0 or 0 is 0. 1 or 0 is 1. 0 or 1 is 1. 1 or 1 is 1. 0 or 1 is 1. 1 or 1 is 1. All right, now, if you recall from our discussion about the Bitwise-AND, wherever the mask was a 1, it left the bits alone. Wherever the mask was a 0, the Bitwise-AND cleared those bits. We have a very different operation going on here. Where the mask is a 1, the Bitwise-OR sets bits to 1. All right? Where the mask is a 0, it leaves bits alone. All right? So this gives us the ability to figure out how to turn on bits, how to enable, how to put ones in specific positions. All right? Now, once again, I know that it may have been confusing whenever you looked at some sort of a logical operation, whenever you first started learning how to program in Java or PHP or C, and you noticed that in order to do a logical AND, like if this is true and this is true, there were 2 ampersands, and I showed you how the reason why 2 ampersands were used was because 1 ampersand had already been taken. It had already been used by the Bitwise-AND. The same is true for the vertical pipe. Okay, that vertical pipe, the vertical line that is on your, that one that you use for the OR, the logical OR operation, the reason why it's 2 of them is because the Bitwise-OR uses a single vertical pipe. All right, so let's first of all, real quick, define exactly, formalize the definition. We're going to say Bitwise-OR sets. It is used to set bits. So it sets bits where the mask is a 1, in those positions where the mask is a 1, and it leaves bits alone where the mask is 0. All right, so last time we talked about how do we make it so that a randomly generated number is even? Well, we can clear the last bit, right? How do we make sure that how do we make sure that a random number is a random odd number? Well, we could make the number even and then add 1. That's a 2-step process, a little messy. Much easier way to do it. I could make, if A has been generated as a random number, I could make sure that it is odd by doing an OR with a 1. That is all it would take in order to make it so that we have forced A to be an odd number. All right? In our previous lesson, we showed how we can use the bitwise AND in order to clear bits. Now we're going to show how to set them. Remember, we had this bitwise operation that took our original color, 1, 2, 3, 4, 5, 6. So there was our 24-bit hexadecimal color. And the AND, we used the AND and some bit shifts in order to shift things around so that we could have these isolated red, green, and blue values. And then what we did was we cleared just the green value in anticipation of setting it to a new value. The suggestion was DC. All right, so let's go ahead and open up our code. So right here is where we take our color and we clear out, using the bitwise AND, we clear out the green. What we want to do now is have a new green, and we're going to set our new green equal to 0xDC, a hexadecimal DC. Now, how do we get that new color in there? Well, the way we get the new color in there is that we take color and we do a bitwise-OR. Remember, the bitwise-OR is the vertical pipe, the single vertical pipe. And we're going to OR it with the green, our new value of green. Now, the problem is right now green is set down to those lower 8 bits. And what's going to happen is it's going to stomp on the value that has blue. All right. In fact, let's go ahead and leave that there and see what happens. So we'll save it, exit, 1, 2, 3. Compile it, run it, and there you go. Wow, that wasn't exactly what we wanted at all. In fact, what ended up happening was the 5, 6 got OR'd with DC and became DE. Does that make sense? Well, a bitwise 5, a 5 is in binary 0101. A D is 1101. So when we did a bitwise OR of a D with a 5, the positions where there were 1s for the 5, there were also positions of 1s in the D. So the D took over. It basically became D. The 2 to the 1 position, that second to least significant bit position, was a 0 in both a 5 and a D, so that was why it left a 0. What happens when you do a bitwise, what you happen to do a bitwise OR of a 6 with a C? Well, C is 1100. 6 is 0110. The only bit where both those values have zeros is the least significant bit, so our resulting value was 1110, or an E, which is exactly what is showing up there, right? So what do we have to do? We have to make sure that the positions get moved, the positions for the green get moved back up 8 positions. And so we go into the code, and all we have to do is take green and shift it left by 8 positions. Now what happens is our DC, notice over there that our DC is set up in the green position. Cool. All right. And that's really all that is needed for a bitwise OR. A bitwise OR can be used in order to set the bits, in order to force a certain pattern of 1s and 0s in those positions.